Hey everyone, we're going to talk about rational equations. I still remember whenever I finally realized why they call it a rational equation. It's just an extension of the word ratio, and ratio means fraction. And that's what we're looking at is we're looking at these equations that are more or less a group of fractions put together. And with these fractions, of course, they get more complicated. Instead of just one half, one fourth, one third, they're going to contain binomials and polynomials in there. And the whole premise of dealing with rational equations is to clear the denominators. No denominators, and then we just have a normal equation. So just clear the denominators. They're no longer a fraction. And you do that by multiplying all the terms by the least common denominator. Okay, so real quick on the least common denominator. If you remember any of your work in grade school, they would get mad at you if you had some fraction like this, 1/2 plus 1/4, and you didn't realize that 4 was your least common denominator. So what you did was you just multiplied them both together and you said, okay, 8. Well, they would say, well, that's not the least common denominator. Well, guess what you're going to do in these problems? Yes, you're just going to multiply everything together. So we'll take a look at that just here in a second. But one thing I did want to talk to you, and this is just concept and how you think, is, and I need you to be able to see this and understand this. Dividing or multiplying by the reciprocal, it's the same thing. So if I had something like this, is if I had, and we'll pick an easy one. If we said 12, and I'll write it as a fraction, divided by 3. 12 divided by 3. Well, you know the answer to that. That's 4. But I could also say this. I could say 12 times 1/3. 1/3 is the reciprocal of 3. And hopefully this way you can visualize it. I could rewrite this problem. A fraction is a division problem. I could rewrite it as 12 divided by 3, like that. Or I could write it as a fraction. But now I hope that you see that visually, oh, well, just saying 12 divided by 3 is the same as saying 12 times 1/3. Because I could put this over 1. 12 times 1 is 12. 3 times 1 is 3. So the reason I say this is sometimes if I ask y'all a question, for instance, 48 divided by 6, some in their brain think, okay, what times 6 gives me 48? So they view it as multiplication. Others actually do the division. Actually, division is a form of multiplication. So, however you think of it, that goes with all your problems. The way that I show you is not the only way in which to work it. So let's take a look at an example. And I already have it written out. This is what I want you to do is I want you to solve 1/4 plus 1/5 equals 1 over t. And I'll help you out with it. Find the least common denominator, the LCD, and this is what I mean. All you do is multiply all your terms together. 20t will be your least common denominator. So you're going to multiply 20t to all the terms. And this is a term, and this is a term, and this is a term. This is what we call each individual thing in the problem separated by a mathematical operation or an equal sign. So if you want to pause it, work through it and see if you end up with the same answer as I have. Alright, so let's take a look, and I'll just uncover everything. So whenever I multiply through by 20t, what I end up doing is doing some simplification. 4 can go into 25 times, so at least 5t, and 5 will go into 20 4 times, so at least 4t, and my t's cancel here, so I'm left with 20. And look at that, I've cleared my denominators, and now I'm left with a basic equation. All you do is simplify. I end up with the answer t equals 20 divided by 9. Now here's the issue with rational equations, and this is why they're special. They have something called asymptotes, and we'll get into that in a later section. It's just where the graph is undefined. So one thing that you have to do every time you do a rational equation is, even though you got an answer for it, you have to take that solution and plug it back. You have to evaluate the function at the value that you found. because some solutions will not be true. And the reason is because if one of those solutions makes a denominator go to zero, you cannot divide by zero. And the reason is because the closer that your denominator goes to zero, we'll look at it. We'll just do something simple. We're going to say 5 divided by 0.0000000000000 9. How about that? This is a huge number. That means that 14 in there is scientific notation and says that it's going 14 places. That decimal is going to be moved 14 places over. The closer you get to zero, your answer becomes infinitely large. And that is the reason you can't divide by zero. Okay? So zero in the denominator is undefined. So anytime we have a solution and when we plug it back in, it'll make a denominator go to zero, then it's undefined at that location. So what I do is I say, okay, t equals our solution, 20 over t, and I plug it back in and I solve to see if it is correct. And for that example, it was correct. Let's look at a different one with a different type of denominator for you guys. Okay, so another example, and you're just to solve. So now I have binomials for my denominator. Well, since they're both the same, that's going to be my least common denominator. I multiply all terms by my least common denominator, and see, they cancel. They're the exact same thing, so they cancel out, and I'm left with 49 minus w squared. I solve, I end up with w is equal to plus or minus 7. Principle of square roots, take the square root of both sides. The problem with it is that whenever I turn around and I solve for w equals 7, I end up with zeros in my denominator because 7 minus 7 is 0. W equals 7 is not a solution. It's actually going to be an asymptote. It's a place where that graph will not be. But for w equals a negative 7, it is a solution. So this is what I do whenever I work problems that are rational. As soon as I look at this, I see, oh, well, if w is 7, I'm not going to have a solution. And over to the side, I just make me a little note, okay? Not 7. So, because I will I will do this to where I forget to plug back in and actually look. So whenever you work your homework problem, it's going to ask you for the solutions. You type it in, and all of a sudden it says it's incorrect, and you go back and you rework, and you're like, it's all good. You have to verify to make sure that one of the solutions or both of the solutions do not make it turn into 0. All right, so your turn to do one. That's a y, which is just a funky looking y. Okay, so this is, I want you to pause the video, see if you can solve it, and then we'll turn around and we'll see if we get the same answer. All right, so let's take a look at it. We need to find our least common denominator, correct? Our least common denominator. And I'm going to multiply all of them together. But see, I have an issue here because I have y squared minus 9. Well, I need to factor that out. And what I know that y squared minus 9 equals is y plus 3 times y minus 3. Right? Y times y is y squared. Y times negative 3y, 3 times y plus 3y. 3 times the negative 3 is a negative 9. Those cancel. Y squared minus 9. See, so I have this. So that's one of my terms. That's for this one here. Y plus 3 and y minus 3. We already have a y plus 3 in there, right? So I don't need to add that twice, and then I have a y. This is my least common denominator. So I need to take this and I need to multiply it to each term in my equation, rational equation. So y plus 3, y minus 3 times 6 over y plus 3 plus y times y plus 3. And I write it out. And now cancel. See, that denominator's now gone, leaving just those two terms. That denominator's gone. And again, remember, y squared minus 9 is the same as y plus 3, y minus 3. That's gone. So now I just do my multiplication. So I'm going to rewrite it out some here. So 6y times y minus 3. I'm going to clean it up. And this y plus 3 and y minus 3 is simply y squared minus 9, so that's how I'm going to write it here. Again, all I'm doing is cleaning it up because my work looks busy here. I need to make sure that I can see all my stuff and not lose track of anything. And y times 5y minus 3. Alright, I just distribute the terms outside of the parentheses. That turns into 6y squared minus 18y plus 2y squared minus 18 equals 5y squared minus 3y. I'm going to combine my like terms, and then I'm going to move everything over to one side of the equation. Alright, so that becomes 8y squared, 2y squared plus 6y minus 18y minus 8. Now I'm going to move these terms over, so I'm going to subtract 5y from here. That gives me 3y squared, and then I'm going to add 3y over to here, and that gives me minus 15y. Now I'm going to factor out a 3, and that leaves me with y squared minus 5y minus 6. I factored out the 3 because this allows for simplicity of solving this trinomial, this quadratic. I can factor this a lot easier having my a term as a 1. And then whenever I factor this, this turns into y minus 6 times y plus 1. And if you remember the principle of zero products, I'm going to set all these equal to 0. Same with 3, okay? And really, you don't even have to, all you're worried about is right here, okay? Because even if I took a 3 and I multiplied it back into them, I'm still going to get the same answers. So I just set these equal to 0. So I know that I have solutions of 6 and negative 1. And what I do is I then verify. I plug each one of these values into my denominator to see if any of these will go to 0. And just looking at it, you can tell nothing's going to make these 0. That ends up, if I plug in a 6, that ends up being 9, 6, and what is this, 36 minus 9? So 27. And same with the negative 1. None of these will make it go to 0. These are both solutions. Okay, so with your rational equations, the problems can look complicated, but all it's doing is tying in your factoring and working with all what we've already done. With that, the main thing that you got to remember with rational equations, all you're doing is removing the denominator, and you're going to end up with an equation that you've already dealt with before in a prior section. So, continue to watch the videos from the publisher, read your text. I need you to structure and critically think about your homework and the problems that you're working. And whenever you work them, act like you're teaching somebody. Talk about it as you do it. Write down little notes. Write down your formula each time. Say the stuff. Alright guys, good luck with the rest of your homework.